Okay, so we have another problem asking us to find a particular term in the binomial of expansion of x minus 1 over 2y taken to the 9th power. So first thing I will look out for is I try to understand what is my degree or my power I'm taking the binomial to. So this helps me remember that my degree is 9. So this will help me figure out right away that I will be looking at the format. If I am looking at the coefficients, I should be seeing 9 choose something. That's a question mark if you're not sure. Let me make it a little bit better. Now, this could help at first. We don't have to keep expanding everything out. But we do know that whenever we're starting off with expanding without even dealing with powers or anything like this, anytime we're looking at binomial theorem, we look at who's the first term, second term, third term, fourth term, etc. We're always starting off with the degree choose 0. So this helps us with understanding, okay, the second term would be the degree choose 1. The third term would have the coefficient degree choose 2. Fourth term, degree choose 3. And then this sort of pattern recognition helps us see that if we are comparing the term number to the second number, sometimes we call this R, in the binomial choosing part, we do know that that term number is always 1 more than what we see in that second number part. So we could extend the pattern, and it's not too hard. If you want to write out who's the 5th term, who's the 6th term, who's the 7th term, feel free to. You can. It's not that rough to understand, but we do know it's 9 choose something, and if it's 1 less than the 7th term, we should end up having 9 choose, you guessed it, 9 choose 6. So that helps us understand what that second number is. So this number, 1 less than the term we're on. So we have the term number minus 1. So again, if we have the 7th term, 7 minus 1 equals 6. So this is a nice way to build up who the coefficient is. So I'll start off. My 7th term, I do have binomial coefficient. This will be 9 choose 6. So having that, what's also interesting is that this second number always matches the power of our second term. So if I'd like to remind you, in terms of if we're looking at our original binomial, the first term in the binomial, and don't confuse this with the binomial expansion, but we do have the first term is x, and again, the second term of the binomial is actually negative 1 over 2y. We'll take the sign with it. So what this tells us is that if we take negative 1 over 2y, we should also be raising it to the same power as we wrote in our second number. So notice that they match. So now all we have to do is figure out the power of x. And x, it's just the first term. But remember, they have to add up to the degree. So if we're trying to figure out what to place right here, you're just saying 6 plus what equals 9? Well, 6 plus 3 equals 9. And that's kind of where the formula comes into play. Like, what do they say? X, n minus r minus 1. But I really do this with patterns as opposed to memorizing a formula. So now all you have to worry about is computing these particular values. So you can use the value of the TI if you want to pull that up. Sometimes like I don't bother with writing things out by hand if I don't have to. I might just look at 9 choose 6. What is that on our TI? So we'll switch over really quick. And if we're going to do 9, choose 6, I press the 9 first. I press the math menu, scroll over to probability. That's item number 3. And I'm looking for 9, choose 6 to give me my coefficient. So right away, 84. I think the last example we did it by hand, but why if you have the beauty of your TI? So I do have 84. I'll switch back. So right away, I was able to find that coefficient. From here, all I do is simplify the powers. So x cubed is still x cubed, nothing different there. Now I just got to be careful about my fraction in a way. So kind of keep in mind, again, if you do see a negative, if you're raising a negative number to an even power, you do have a positive term. And then we kind of use properties of exponents. What do we have? 1 to the 6th is 1. And then we'd be looking at 2y to the 6th. If that's something that you want to take a little bit of an extra step on. So we have 84 x cubed. Now 1 to the 6th is 1. And 2 to the 6th, what do we have to do? I'll probably use my TI if I don't have that memorized. That's totally okay. We do have a 64. And then y to the 6th. And if you don't mind, I'll draw this in green just so that we're color coding. So we have x cubed 1 over 64 y to the 6th. And so now it's a matter of just making sure everything's as simplified as possible. So for one thing, you are multiplying a whole number by a fraction, so you could put it over 1. I do see that x cubed would be in the numerator, y to the 6th in the denominator. And then we're kind of looking at what is 84 over 64. We'll just do our best to reduce that to lowest terms. I do see that they're both even numbers. Just pull out your TI really quick. That takes a little bit of pressure off of us. And we do have, what is it, 84 over 64? So really quick, 84 over 64, use the math key fraction, and it reduces our fraction to 21 over 16. So we go back. We have 21 x cubed over 16 y to the 6th. And that is the value of our 7th term without having to expand out the entire binomial. So practice these a little bit more. Recognize the pattern, then you don't really have to memorize any specific formula. You just kind of keep the binomial theorem in mind, and you will do just fine. I think we have another example to go. I will see you then.